Let's see a few things about coordinate geometry, children. Let's have a recap. First thing we learned in coordinate geometry, children, was distance formula. Distance between 2 points. Coordinates of the first point is x1, y1. Coordinates of second point is x2, y2. And the distance between the two, the distance between the two, the length from here to here, that's distance between the two, is given by distance AB is equal to the whole square root of x2 minus x1 the whole squared plus y1 minus y2 the whole squared. Now children, let's see an example to understand or elaborate on that. What points on x-axis are a distance of 17 units from the point P 11, -8? The question says, what points on x-axis are at a distance of 17 units from point P, coordinates 11, -8. So children, we'll draw a diagram over here. There is a point R whose coordinates are a, 0 since it's on the x-axis. The distance is 17 units and the coordinates of P are 11, -8. Now children, we write down over here x1, y1, x2, y2. Write distance formula. That distance PR is equal to the whole square root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared. That's 17. We square both sides, children. So 17 squared is equal to a minus 11 the whole squared plus 0 minus 8 minus 8 the whole squared. That's 17 squared minus 8 squared is equal to a minus 11 the whole squared. Which by difference of two squares becomes, children, 17 minus 8, 17 plus 8. 17 plus 8 is 25. 17 minus 8 is 9. So children, we get a minus 11 the whole squared is equal to, when you 25 times 9 only, when you square root both sides, children, so we get a minus 11 is equal to plus and minus 5 times 3, that's 15. So a is equal to 11 plus or minus 15, children. So that would give us the values of a. Since they said points, points would come out to be, the abscissa of that would come out to be, that's 26, or a would come out to be -4. So the coordinates of R would come out to be 26, 0, or R would come out to be -4, 0. That would be it would be necessary to specify this as coordinates, children. We always need to write down the coordinates, children. That's distance formula, children. Now we have section formula. Next thing we have is section formula, children. In case of section formula, the formula is, if a line with points A, x1, y1 and B, coordinates x2, y2 is divided by another point P in the ratio x is to y, with the ratio being m is to n, then the coordinates of P of x, y comes out to be mx2, it crisscrosses, children, mx2 plus nx1 upon m plus n. And for y, it becomes my2 plus ny1 upon m plus n. So children, let's see an example to elaborate that. Question says, in what ratio is the join of P -4, 2 and R 8, 5 divided by the x-axis, divided by the y-axis? Also find coordinates of the point. Now children, first we'll draw a diagram and write down the formula for the same. So that's P having coordinates -4, 2, R having coordinates 8, 5, and divided by the y-axis means abscissa is 0, take the point as A, so 0, A. Ratio being m is to n. Now the formula for this, children, the abscissa part, that's A of x would come out to be mx2, x1, y1, x2, y2, x, y. mx2 plus nx1 upon m plus n. The abscissa is 0. That's m into 8, so that's 8m plus -4 times n upon m plus n. M plus n cross multiplies, so we get 8m is equal to 4n, or m upon n is equal to 4 by 8, that's half. Once we have this, children, once we have m upon n as 1:2, m upon n is 1:2, that's the ratio, m is to n is equal to 1:2. Now for the coordinates, children, we need to find out A. M is 1, n is 2. So children, for that part, that's A of y, the ordinate of A would be given by my2 plus ny1 upon m plus n. That's, children, A is equal to 1 times 5 plus 2 times 2 upon 1 plus 2. That's 4 plus 5, 9, 9 by 3, which is 3. So the coordinates of A, children, come out to be 0, 3. This is the way, children, we apply the section formulae and solve sums. Now let's see the next, that's midpoint formula, children. Midpoint formula, children. It's the midpoint between two. It's the point which bisects the line. It bisects the line, that's A, x1, y1, B, x2, y2. The point P, children, the point P bisects the join of A and B. So the coordinates of P of x, y is given by x1 plus x2 by 2 and y1 plus y2 by 2, children. That's an application of this formula, children. So this sum says, children, prove that the points P -2, -1, Q 1, 0, R 4, 3 and S 1, 2 are vertices of a parallelogram. So children, what do you have to do in a sum like this? You have to prove it to be a parallelogram, children. We need to remember the properties of a parallelogram. The properties of parallelogram include the most basic one which you're going to use over here using midpoint, children. The diagonals bisect each other. So midpoint of PR, that's this point A, has the same coordinates as midpoint of SQ. So children, first we have the formula, that's midpoint coordinates x, y is given by x1 plus x2 by 2. The average, children, the average, and y1 plus y2 by 2. So here you need to prove it's a parallelogram, children. So we'll find the midpoint of PR, that's midpoint of PR, children, would come out to be, the coordinates being -2, -1 and R being 4, 3, would come out to be -2 plus 4 upon 2, -1 plus 3 upon 2. That's 2, 2 upon 2 is 1. That's again 2, 2 upon 2 is 1. That's the coordinates of midpoint of PR. Same way, children, now we're going to get the midpoint of QS. Midpoint of QS, children, would come out to be the same way. Coordinates of Q is 1, 0. Coordinates of S is 1, 2. So abscissa would come out to be 1 plus 1 by 2. And this would come out to be 0 plus 2 by 2. That comes out to be 1, 1. Since these two coordinates are the same, we can say PR and QS bisect each other. Therefore, quadrilateral PQRS is a parallelogram since diagonals bisect each other. So children, this is how we use midpoint formulae to come to the conclusion that we need. The other formula, children, is the intersection of medians. The point of intersection of the medians, that's called a centroid. The centroid is the point of intersection of the medians. That means this is equal to this, this is equal to this. A median bisects the base, the median bisects the base, and centroid divides the median in the ratio 2:1. Centroid divides the ratio of this divides the median in the ratio 2:1 and 2:1 if it matters, children, for this part. Well, this proof of it divided in 2:1 is a sum which you've done in similarities. So for now, the coordinates of A, B and C being x1, y1, x2, y2, x3, y3, and the coordinates of G being x comma y is given by G abscissa comma ordinate is given by x1 plus x2 plus x3 upon 3, the average, comma y1 plus y2 plus y3 upon 3. So that gives us, children, this is the formula we're going to use for centroid. Now let's see a sum in which this will be applicable. The question says, find the coordinates of centroid of triangle ABC. Find coordinates of centroid of triangle ABC having coordinates A 6,3, B -2,5 and C -1,7. So children, that will give us the coordinates of centroid G x, y. The formula is just above. So I'm not writing it down again, children, but you're supposed to write it down. Every formula has to be written down. That's 6 minus 2 minus 1 upon 3, comma 3 plus 5 plus 7 upon 3. That gives us, children, the coordinates of G would come out to be, that's 3 upon 3, 1, and that's 15 upon 3, that's 5. So the coordinates of the centroid come out to be 1, 5. So children, you must remember all the formulae, apply it as with the help of a diagram, it will make things easy. Now for equation of a line, children, equation of a line, first we discuss slope. Slope of any line with the help of two given points, like this is a line and this is the x-axis. The angle it makes from x-axis to the line, from x-axis to the line is the angle theta. That's called inclination. That's called inclination. This angle is inclination. Inclination. Well, slope, children, slope given by symbol m or gradient. Slope or gradient, children. Remember, the term used can be slope or gradient. Means the same, is given by change in ordinate upon change in abscissa. It's also given by, children, plus or minus tan theta. Now, in this particular example, the angle is going in anti-clockwise direction. Anti-clockwise is positive. But when if it goes in this direction, which is clockwise, and this is clockwise, like if you take from the x-axis line either here or here, it's still going to be clockwise. It's going to be clockwise. And in case of clockwise, children, it is clockwise is negative. So children, the slope is either positive tan theta or negative tan theta, depending upon whether it's positive, whether it's clockwise or anti-clockwise. Now children, slopes of parallel lines are equal. Slopes of parallel lines are equal. If lines are parallel, slopes are equal, because if I draw a line over here, children, which is parallel to this line theta, the angles will be the same. Since the lines are parallel here, that's corresponding angles are equal, which make the slope of this line as tan theta, the slope of this line as tan theta. So slopes will be equal for parallel lines or collinear points. Collinear means on the same straight line, children. Collinear means on the same straight line. So that means if there are 3 points A, B and C, they are on the same line, slope of AB will be equal to slope of BC. So slope of AB will be slope of BC. They will be equal. That's why I've written as M1 is equal to M2. And product of the slopes is -1, children, when the lines are perpendicular. If lines are perpendicular lines, product of slopes is -1. Now children, let's see some application of slope. For example, children, if you've got a question like this, prove that, similar to what the sum that we did earlier, prove that points P -2, -1, Q 1, 0, R 4, 3 and S 1, 2 are vertices of parallelogram. Are vertices of parallelogram. So in such a case, children, what we need to do is, first we draw a diagram, and to use slope, children, we'll prove opposite slopes equal. That's P, Q, R and S. Coordinates -2, -1. q1 comma 0, r4 comma 3, and 1 comma 2. Now this we're doing using slope. Children, remember when they ask you to prove a parallelogram, they will not specify in the question to do it with the help of distance formulae, that's midpoint formulae, or you need to do it with the help of slope. It's up to you, it's left up to you. I've shown you by midpoint, I'm showing you by slope. So children, we'll find the slope of PS and QR, since we can see that they should be parallel. Slope of any line is given to you by change in ordinate upon change in abscissa. That's the formula for slope. So we'll first generalize the formula for slope as this. Now we'll find a slope, that's slope of PS. Slope of PS will be given by y2 minus y1 upon x2 minus x1. That's 3 upon 3, that's 1. Immediately children find a slope of QR, that's y2 minus y1 upon x2 minus x1, which also comes out to be 1. Next children, we'll find the slope of the other parts, that's slope of PQ. Again y2 minus y1 upon x2 minus x1, that comes out to be minus 1 by minus 3, that's 1/3. And then slope of SR. Slope of SR children will come out to be y2 minus y1 upon x2 minus x1. y2 minus y1 upon x2 minus x1 children, that comes out to be 1 upon 3 again. But remember children, if you take y2 minus y1 upon x2 minus x1, if this is y2, this is y1. y2 minus y1 upon x2 minus x1, this is x2 y2, this is x1 y1, or this is x1 x2 y2 and x1 y1 children. Do not mix them up. The moment you mix them up, your answer will come wrong. Now let's see another, so that proves the two lines parallel here and the two lines parallel here. Therefore quadrilateral PQRS is a parallelogram since opposite sides are equal. Now children, let's look at equation of a line. For equation of a line children, as we have learned earlier, we've got this one most important equation we're going to use, that's point slope form. That's point slope form, and point slope form states if you've got the coordinates of a point x1 y1 and the slope of the line, equation will come out to be y minus y1 is equal to m times x minus x1. Children, the point can be anywhere on the line, the point can be anywhere on the line, but the condition is should be on the line. The point cannot be out of the line, children. Then that's not the equation of that particular line. We need to have the gradient or the slope of that particular line and the coordinates of any point on the line. The equation will come out to be the same, children. And the other one which we use most commonly, that's slope y-intercept form. Slope y-intercept form is y is equal to mx plus c. But children, this we're going to use very rarely. We're going to use mostly y minus y1 equals to m times x minus x1. This, if we have the equation of a line, to get the characteristics of the line, the y-intercept and the slope, we're going to work backwards with the help of this formula. Let's see some examples of finding the equation of a line, children. Question says, find the equation of a line whose y-intercept is minus 3 and passes through minus 1 comma minus 3. Now children, to do a sum like this, children, we've got the y-intercept, so the coordinates of a point on the line, y-intercept is also a point on the line, so it will be 0 comma negative 3 on the y-axis. Abscissa is 0, on the y-axis abscissa is 0, ordinate is negative 3, and this comes out to be negative 1 comma negative 3. So children, what we'll do is we'll find the slope of the line, that's gradient or slope is given by y2 minus y1 upon x2 minus x1, that's minus 3 plus 3 upon minus 1 minus 0, that's 0. So slope of the line is 0. So the equation of the line will be, you can take any one. Now children, we can use this formula or we can use this formula. Only for this time I'm going to use both and show you how either of them will work. We can use y is equal to m x plus c as y is equal to 0 times x plus c, which is minus 3. So equation comes out to be y is equal to minus 3. Or conversely, children, remember any one. Do not try to remember both. It will only confuse you. Try to remember any one, children. Any one. Equation the other way is y minus y1 is equal to m times x minus x1. So that's y minus y plus 3 is equal to 0 times x minus 0. Whole thing becomes 0. Y is equal to negative 3 becomes the equation. Whether you look at it as y is equal to mx plus c way or y minus y1 equals to m times x minus x1. But children, usually to find out the equation of a line, we'll use this formula only. It's much relevant and much more useful to find the equation of a line. But in the next example, they ask us for the inclination. Question says, find the inclination and y-intercept of the line with equation 2y minus 2x plus 6 is equal to 0. So here, children, what we're going to do is we're going to make y separate to the formula. That's 2y is equal to 2x minus 6 divided everything by 2. Y is equal to x minus 3. Comparing it with y is equal to mx plus c, children. M on comparison comes out to be 1. C on comparison comes out to be negative 3. So that's m is equal to 1, which is equal to tan theta. And for that value, children, tan value for which it's 1 is 45 degrees, and C, the y-intercept, is negative 3. So this way, children, we can find the equation, the characteristics of a line, of the degree of the slope, the inclination and the slope of the line, and also the y-intercept using y is equal to mx plus c. An equation of a line is found out using y minus y1 equals to m times x minus x1. Also remember, children, if you want to find a point of intersection of two lines, solve them simultaneously. Solve them simultaneously to find the point of intersection, children. Now, children, let's see a little bit of reflection. Let's refresh our memory on reflection. What was reflection all about? Children, for reflection, what we had, if you got a coordinates of a point as x1, y1, so the coordinates of a point as x comma y, and it's reflected in the x-axis. In x-axis, ordinate changes sign, children. So it becomes a dash x comma negative y. That's in x-axis, ordinate changes sign. Even though it's x, ordinate changes sign. Same way, children, if it's x comma y reflected in the y-axis, equation of x-axis, children, is y is equal to 0. Equation of y-axis is x is equal to 0. They mean the same, children. Gives us a double dash absolute changes sign, children. Absolute changes sign. Says ordinate changes sign. Ordinate changes sign. Where it's abscissa changes sign. Now, children, another point x comma y was reflected in the origin 0 comma 0 or the origin. Origin, children. It gives you the coordinates of a point where both change sign. Both the points change sign. But, children, if you have a point on the mirror line, like for example, children, you've got a coordinates of a point B as x comma 0, and it's reflected in the x-axis. X-axis, children, we know the ordinate changes sign. It is, and this point is on the x-axis. The point x comma 0 is on the x-axis. When that's reflected to give you b dash, it'll still remain the same. It doesn't change, does not change. So this is called an invariant point. A point which does not vary or change under reflection. It does not change under reflection, children. It does not change its position under reflection. That's called an invariant point. Let's see an example to elaborate on that. Question says, a point P, coordinates A, 3 comma 4, is reflected to P dash in x-axis. O dash is the image of O, the origin, reflected in line in line A dash. Write the coordinates of first, write coordinates A dash and O dash, also the length A dash and O dash. Find the perimeter and find the perimeter in area. Find the perimeter and area of the figure or of the quadrilateral, and classify the quadrilateral. So children, here we've got A as 3, 4 when it's reflected in the x-axis, or y is equal to 0. Use your A dash, children, in x-axis, ordinate change the sign. So that becomes 3, -4. I'm just drawing a small graph over here, children, so that we can analyze and come to the final conclusion as to how things are going to be. So it's 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. If you need, we'll draw it further, children. And 1, 2, 3, 4. 1, 2, 3, 4. X dash, y dash. 3, 4, children, will come over here. That's A. It's reflected in the x-axis, children, so it comes down to give you coordinates as 3, -4. That's A dash. So that's that line, if it matters. Now children, O is this point. O is this point. It's reflected as 3 units here, so it'll come 3 units over here. That's coordinates of O dash. So O 0, 0 reflected in the line A dash will give us O dash, whose coordinates would come out to be 6, 0. That's the first part, children. That's part A. B part, they ask us for the length of A dash. You can count, children. We literally count it. That's 1, 2, 3, 4, 5, 6, 7, and 8. So children, we can write down that thing as A dash is equal to 8 units and OO dash is equal to 6 units, children. C part, find the perimeter. So when we connect this, children, we can connect it like that. So it's 3 and this is 4. So by Pythagoras theorem, this will come out to be 5. Same way. It's going to be 5, 5, 5, 5 everywhere. So children, the perimeter would come out to be 4 times side. For the side, children, we'll show the calculation of where side is equal to root of 3 squared plus 4 squared, which is root of 25, which is 5 units. So perimeter is equal to 4 times 5 is equal to 20 units, children. And area, children, this would come out to be a rhombus since the diagonals are perpendicular bisectors of each other and are unequal. Diagonals are perpendicular bisector of each other and are unequal. So it will be a rhombus, children. That's the D part. The quadrilateral is a rhombus. Area of rhombus, children, we must remember, is half into product of the diagonals. Half into product of diagonals. That's the specific reason why they've asked us to calculate this, children. It's half into 8 into 6. That cancels to give you 4 times 6 as 24 units squared, children. So that's all the answers that they needed. This, the coordinates, the perimeter, and the rhombus. That's the end of coordinate geometry, children. Thank you.